Lesson 4, the remainder theorem and the factor theorem. So this is a theorem that we're going to use to help factor things out. So just a couple of quick reviews here. Use synthetic division divide. So this will help those of you guys gone. You know, like Cole, you might remember this, but since you were gone, this can help refresh. So if we're using synthetic division for this polynomial, it would be 1, -2, -4. There is going to be a what? Well, we don't know that yet, Ollie, but that's a good guess. Okay. Yes, there's going to be a 0 spot, is what I was saying. We're missing an x, yeah? X cubed, x squared, there's no x and then a constant, so we have to have a placeholder for that spot. That's what a lot of you guys struggled with last class on notes. So it's going to be 1, -2, 0, -4. That 0 is there to hold the place for the x term we don't have. Okay, you have to have a value for every degree number counting down. Okay. So we do synthetic division here. We drop the 1, -1, -3, 3, 3, -3, -7. Okay, and then we're doing that thing we talked about last time where if we plug in -1, we know we're going to get -7. Okay, so this is how we can kind of draw this all together, and this is what I was going to tell you. So that's going to be -1, that's going to be -2, that's going to be -4, which gets you the -7. It's not a coincidence. So this might, Leah, this actually might kind of bring forth what you were kind of saying. So if I told you if you get a remainder of 0, that means it's a 0, right? In the graph. And when we plug zeros into the original, what do you get? Right, this is being redundant, right? You get a 0. Well, look what happens here. When we do our synthetic division, it says our remainder is -7. So what that means is that's the value that that point is in the original. Let me say that again. By testing -1, if -1 was a 0, this would be 0. It is not. It's -7. That's actually where it's at in the original. So the original is -1,7. That's why we just got -1,7 here when we plugged it in. Okay? So that remainder value is the value where you're at from the original. So that one we got -239 in the notes. So we were at -239, okay, in the original. That's our remainder. So let's try this one. Do it again. Okay. So we got x -2, so I'm doing 2. We got 1, -2. This one's straight. I don't have to worry about any extra zeros. It's 2, 1, 0. Drop this down. 2, 0, 0. Whoops. -5. So there's my remainder there. If you put 2 into the original, we get 4 -4 -5, which is -5. So it's hammering away that concept I just said. Your remainder is what the value would be if you plugged it into the original. Okay. So complete the following observations based on what we just wrote down. So when p of x is x cubed minus 2x squared minus 4, the remainder is equal to p of -1. And then this one's the remainder is equal to p of 2. Okay, so the remainder theorem. First thing we're going to talk about, remainder theorem. When a polynomial function p of x is divided by a polynomial of x minus a, the remainder obtained is equal to the value of the polynomial x equals a for the remainder of p of a. That's just stating what we just did. Okay, here's the proof of it. But essentially what happens is you're going to get 0 in the quotient. Because remember, I said if it's a 0, then you're going to get 0, right? So see 0 plus 0, like if you thought the remainder was 0, 0 plus 0 is 0. So it is a 0, which is a lot of zeros, I'm sorry. Okay, but this is kind of just the proof of it. I think we can just go right to the examples. Okay, so use the remainder theorem to, for p of x, 6x cubed minus 4x squared plus 8x plus 6 is divided by x plus 1. So with the remainder theorem, we essentially kind of have, I don't like saying shortcut, but we kind of have a shortcut. We don't need to synthetically divide that to get the remainder. We can just plug it in. So if you're getting all in your head, I have synthetic divide, I have synthetic divide. That's kind of that thing on diploma. You're going to waste a little bit of time when you don't have to. We know if it's x plus 1, I'm just going to test p of negative 1 by the remainder theorem. And what you can do is, it's what you're doing, it's really silly, and it probably even seems easier. So I'm just testing to see if it's a 0 or not, right? So I'm just plugging in negative 1. If I get 0, oh, it's a 0. There is no remainder. If I don't get 0, it has a remainder. So negative 1. So negative 1 cubed is a negative 1, so that gets me negative 6. Negative 1 squared is 1, so that's minus 4. 8 times negative 1 is negative 8. And positive 6. So I got these 6's cancel, a negative 4, negative 8. I get negative 12. That is my remainder. How do I know to plug in negative 1? You plug in what makes this 0. Oh, yeah. So what are we plugging on the second one, Ollie? What makes that 0? Close. Positive. We have to add the 1, right? Positive 1/2. Okay, so we're going to try 1/2 on this one. So we're going to go p of 1/2. All right, so this one's a little bit harder because we got to cube a half. But 6 times 1/2 cubed is 1/8 for the 1/2 cube part. Minus 4 times 1/2 squared is 1/4. Plus 8 times 1/2, and then plus 6. So we have 6 over 8 is 3/4. Minus 4 over 4, because that's going to be, so minus 1. 1/2 of 8 is 4, plus 6. If you get worried about the quickness of my fractions, you don't have to go that quick. That's just experience. Okay, don't get overwhelmed. So we got 10, 9, 9 plus 3/4, so that's 9 3/4. So you can write that as 39 over 4. I'm fine with 9 3/4. 9.75 is fine. Okay, all's good. Okay, so don't overthink the remainder theorem. The remainder theorem is simply you plug in the value to the original and it'll tell you the remainder. It's that straightforward, okay? All right. So find A if the remainder, so now we have to do a little bit of algebra with it. Find A if the remainder is 131 when p of x is 2x to the 4th minus x cubed minus a to the x plus 8 is divided by x minus 3. So using synthetic division and then using the remainder theorem. So what we're going to do is we're going to do that part where we use synthetic division and solve for A. Don't forget we're missing a what? X squared. So we have to remember the x squared there is going to be 0 for synthetic. So we're dividing by x minus 3. The thing in the box is a positive 3. And here we go. 2, 1, negative 1, 0, a negative a, and 8. That's the numbers we're going to use. And now we're ready to synthetic divide. Mine's a little close. Maybe I have a little more space if you do it. Okay, so always first step. Drop the 2, multiply. 3 times 2 is 6. Add 5. 3 times 5 is 15. Add 15. 3 times 15 is 45. Okay, so 45 minus a goes here. And we know the remainder, they said, is 131. So if it's 131, how are we going to get 131 from 8? It's an A, sorry. How do we get 131 from 8? So I'm asking you what would go here. Good. That's what's going to go there going this way. I'm asking you to go this way, though, Cassie. So, like, we know that this value plus 8 has to be 131. So what's that value have to be? Right, 131 minus 8, which is 123. So 123 is what this value is, and then what she said is what we're going to set it equal to. 45 minus a times 3 is going to go here. And so that's kind of our equation. I'm kind of going from both directions to form my equation. Because I know coming from the back side, I should have a 123 value in here, but I know that a helps me get there. So you're essentially going to go 3 times 45 minus a equals 123. I would divide the 3 first, just because I know 3 goes into 123 41 times. 45 minus a equals 41, minus the 45, minus the 45. Negative a equals negative 4, so a equals 4. That's the synthetic division way. Okay? Any questions? So now using the remainder theorem, how do we do that algebraically? And the point is that it might be a little bit easier. Right, you're going to plug in the 3 to the original, and we know the output should be 131. So you would say, okay, 131 equals 2 times 3 to the 4th minus 3 cubed, okay, minus a times 3 plus 8. And so you can see we have numbers everywhere except for the a, so we can just solve. Okay, so 3 to the 4th is 81 times 2 is 162, minus 27, minus 3a, plus 8. Now let's move all those numbers away from the a. So let's see here. 162 minus 27 is what? That's 35? Yeah, 135 plus 8, so 143. And then we're going to minus the 143. Okay, that gets me a negative 12. So negative 12 equals negative 3a, and then we get that same 4 we just got. Okay? If I lost you in that last little piece there, I was just combining like terms. Okay, just put my constants together. Okay, any questions on that? Okay, we're on the decline here. Just going to do one more of these, and then we're talking about the factor theorem. Okay, so no question on the remainder theorem? We're okay? All right, come on. Feel free to ask questions, even if you were gone or if you're missing stuff, it's okay. Okay, find the coefficients d and c and p of x equals 2x to the 4th, d to the x cubed minus cx squared plus 5x minus 8. So one thing I want you to take a step back right now. What's the difference between this problem and the previous problem? 2 variables. So if you have 2 variables, what strategies are we going to have to probably use to get these answers that we used yesterday? Right, our systems, right? Elimination, substitution. We're going to have to use a different method other than just simply solving for A. Okay? This is a diploma question type deal because they're going to definitely challenge you on a higher level of solving. Because sometimes as soon as you guys, the more letters you see, the more you freak out. The more fractions you see, the more you freak out, right? So they're going to do that to your disadvantage, okay? So just keep that in mind. All right, so good. This one here, so the remainder is negative 41. Let's see. Find the coefficients. Okay, divided. So in this case, we can just go ahead and go straight to the remainder theorem. That's the point of the lesson. So I'm going to put in p of negative 3, okay? And I'm putting that into for x. So that gives me 2 times negative 3 to the 4th plus d times negative 3 cubed minus c times negative 3 squared plus 5 times okay, wait a second. They already gave me the answer, didn't they? Sorry. We don't have to plug those in. We have to plug them in actually not to get, so we don't, never mind. I'm okay. I still need this. Okay, 5 times negative 3 and then minus 8. So we know that when you plug in the negative 3, you get negative 41. So negative 41 goes here. And then we want to simplify all this so it's just C's and D's. Okay, so negative 3 to the 4th, that's your 81. So it's 162 again. Okay, minus 27D, minus 9C, minus 15, minus 8. So I just want to get this so it's just, like I told you, it's a little bit better if you just have the variables on one side, the constant on the other side. So I'm just going to move this stuff over, leave the D's on the right side. All right, so if we minus this over, add 15, add 8. So minus 162, so that's going to give me negative 203. Negative 203 plus 23, so I get negative 180. One thing about this, what do you notice? Like, see how they're all negatives? You could change them all to positive if you wanted to, if that bothered you, because they all have a negative. You could just times both sides by a negative 1. I won't do that for now. Or maybe we will. We'll see. Yep. So that's your equation 1. Now we have to go get equation 2 from the second piece of information. Yeah, so we have to do that again for 74 and positive 2. Sorry, you didn't like that? 74, 2 times 2 to the 4th, plus d times 2 cubed, minus c times 2 squared, plus 10 minus the 8. So 74, 1632, 8d, minus 4c, 10 minus 8 is 2. So 34 and 74, so that's going to give that 40 for that one. Yeah, 74, 34. So 40 equals 8d minus 4c. Okay, so we come over here, and we're just going to slide this over here for equation 2. So 40 equals 8d minus 4c. Now this one's not as nice. Can anybody see why this one's not as nice for elimination? Yeah. Well, what I see is that 8 doesn't go into 27 and 4 doesn't go into 9. So I run into kind of a roadblock in terms of I don't have a nice, easy elimination like we did yesterday. So we have to get a little creative in how we do that. A couple things that they do here, now this is kind of up to you, but notice that all these have a 9 in common, and all these have a 4 in common. So that actually kind of helps us, because if I divide this whole number 1 by 9, so let's number 1 now is going to be negative 20. I really like that, because negative 180 I don't want to deal with. Okay, negative 27 becomes negative 3. Negative 9 becomes negative 1. 9 divided by 9. I divided 9 to everything. So no, it doesn't go somewhere because you did to both sides. Yeah. Okay, this one 4 to everything. So then that's going to be 10, 2d, and now minus c. Cool. Now we're where we want to be. The c's will cancel if we subtract those, right? The first c should it be positive? I divided by a positive 9. Let's see here. Yeah, but there's a negative here. It was already had a negative on it. Good looking though. That's a good idea. Okay, so now I'm ready to minus. Let's minus it. Travis, if I'm wrong, it'll come up here in a second. Okay, so negative 20 minus 10 is negative 30. I'm minusing because when I minus a minus, it's going to be what? Plus. That's why I'm minusing if you're worried. Okay, so negative 20 minus 10 is a negative 30. Negative 3 minus 2 is a negative 5. And then the c's cancel. So what is d? D is 6. Divide by negative 5, right? Okay, last piece here. So if d is 6, let's put it right here. 2 times 6 is 12. So I'm just going to do that little work right here. 10 equals 12 minus c. Okay, so then what's c have to be? We can kind of just answer that. 12 minus what is 10? 2. So, yep, c is 2. You can do the algebra if you want, but 2 and 6. And those are the correct answers. The 10 and 12? The Okay, I took this equation here, and I plugged in for D. So D is 6, so 6 times 2 is 12. We don't know C. The 10 was already there. So and remember, you can plug into any equation we've used all the way up. Okay? Right, Ollie? Okay?
You can plug it into any equation?
Any of them, all the way up. Okay? Don't take any as anything in the book, just any on this problem. He's like, you said anything. All right. Factor theorem. So the binomial x minus a is a factor. So this is, guys, we've already solved this. The cool part is the factor theorem, we just talked about it today. Look at it. Binomial of x minus a is a factor polynomial, p of x, if and only if you plug it in, you get 0. Right? We already said that. It is a factor if you plug it in and you get 0, no remainder. So it's full circle that we talked about at the start of class. Okay? So note that a is then a 0, the polynomial. So show that x minus 4 is a factor with synthetic division and by the factor theorem. Okay? So what we do is synthetic division. We use 4. Okay? We'll go through this. 1, 2, negative 24. Factor theorem means we're doing p of 4. Okay, just setting them up. Okay, so synthetic division. Drop the 1. 4. 6. 24. 0. That means it's a factor. There's nothing left over. That means it evenly went in. Okay, this one. 4 squared minus 2 times 4 minus 24. Oh, not minus, plus 2 times 4. 4 squared 16 plus 8 minus 24. That is 0. So therefore, remainder of 0, the output is 0. So we just proved that both ways the remainder is 0, which means it is a factor of the polynomial. So the polynomial, if you graphed the original, okay, if you graph this, it goes through the point 4. This is cool because, again, we talked about this. That's why I like it. Because this factors to what? Right? That's what it factors to. So that's the easy one looking at, right? You're going to get much higher than that, but that's just kind of showing you full circle. Okay? Got any questions there, Andy? Okay. Anything else? Okay, let's go and finish this up. Right? Binomial factor with integral coefficients of the polynomial p of x if p of 3 equals 0. So what that's saying is, if it is 0, what's a factor of that polynomial? No. So what it's saying is that if you plug in a 3 and you get 0 the function, what does that mean? What binomial is a factor? X minus 3. Right? We got the 3 from the x minus 3. It's just making you work backwards on what the 0 is. Right? They're not giving the polynomial, right? They're kind of making you understand the level of thinking that if 3 is a 0, then x minus 3 goes into this polynomial. We don't know what it is. The second one's a fraction. Who can see that one? 3x plus 2. Perfect. Now, I like it when you guys are all answering questions. It gets me excited. Okay, good. 3x plus 2. Okay, we got p of 5 equals p of negative 2 equals 0. Determine a second degree factor of the polynomial p of x. So what this is saying is that, remember, if one thing equals 0, they both do, right? So this is essentially saying these are both zeros. So that's saying put those together to form your second degree factor. So it's this simple. X minus 5, x plus 2. That's all it means. Now you have a second degree polynomial, right? X times x is x squared. So they want you to FOIL it out because they want polynomial form. So x squared minus 3x minus 10. Okay. Use a factor theorem to determine which of the following is a factor of 4x cubed minus 16x squared plus minus x plus 4. So which of these? So is x plus 2 a factor? So how can we figure it out? We can simply just plug in -2, right? Just plug in -2. I'd probably do that over synthetic division, wouldn't you? Do you guys prefer that? So just go 4 times -2 cubed minus 16 times -2 squared minus a -2 plus 4. Wow. So that's -8 times 4, so that's a -32. That's a -16 times +4, so that's 64. Okay, and then negative is +2 plus 4. Clearly I can see it is -2 squared. Yes, this one? Yeah, this is positive, but there's a negative here. I missed the negative in front, so Bo's right, so that's where we're at. But either way, you can see that it's not going to cancel cleanly, right? -96 plus 6, so I get -90, so not a factor. Has to be 0, right? (2x minus 1), so we're trying 1/2. Again. Okay. 1/2 cubed is 1/8. 1/8 times 4 is 1/2. 1/2 squared is 1/4. 1/4 times 16 is 4, so -4. And then, I can see it. I like it. 4's cancel. Halves cancel. Yes. Factor. All right, last example here. Show that 1 is a root of the equation x cubed minus 9x squared plus 20x minus 12. Again, back to Math 20. It was lesson 1 of Unit 3. We just did it. That's why I remember exactly the lesson. The lesson topic was zeros, roots, and intercepts all are the same. So when you see roots, you're like, what's a root? It's a 0. Okay? What's a 0? 0 is a intercept. All those things are interconnected. Okay? So if we do that, we got 1. We're doing 1. Just testing it out. Okay, so we got 1 cubed minus 9 times 1 squared plus 20 times 1. Okay, and minus the 12. Okay, and the tricky part of this one is kind of fun to find the other roots. Okay, so if you plug this in, we're going to get 1 minus 9, what's that, plus 20, minus 12. So we have -8, -12, or positive 12, -12, 0. So 1 is a 0. How can we find the other roots without just putting our calculator or anything like that? Synthetic division. Divide that 0 out. See what's left. Okay, so take that 1. Okay, remember, it's a 1, so what's that factor though? X minus 1, right? All I'm saying that for is because this is still a 1. Some people put a -1 there because this was a positive 1. Remember, that is the root. What's that? But the other roots are the other x-intercepts. That means there's more than 1, but good thinking, Aiden. Yep.
So if it does show that 1 is a root, instead of putting like the x minus 1, that's already like the root. You don't have to change it.
Right. They're giving you the actual value. Yeah, right. Okay, so here we go. So we're dividing out x cubed. Not x cubed. Why am I putting that? We don't want to do that. We want just 1. Set up our synthetic here. Minus 9, 20, minus 12. Because we know that's a factor, so we're going to divide it out to get the leftover polynomial. Okay? So, because we're not comfortable factoring an x cubed, right? So if we divide out this, which we know will have a remainder of 0, we're going to have a quadratic left that maybe we can factor, and we can find the other roots. Okay? And if we couldn't, let's say it's not factorable, could we still find the roots? Yeah, quadratic formula, there's a lot of means to find those roots still. Okay? So here we go. 1 times 1, we get the, and if you do this and you don't get it, you get a remainder, something's wrong. Okay? We know there shouldn't be a remainder. Okay, 1, -8, -8, 12, 12, I got the 0, so I'm happy. So what we're saying is we want this. This is the important part. This is what we want. And I like that it's a 1x squared, because that's going to mean it's going to be a nice, easy factorable, hopefully. X squared minus 8x plus 12 that we have. Can we factor that? Minus 6, minus 2, right? This is what they mean. So that means your other roots are 6 and 2. And to put all together to finish the lesson, this big guy here, factored, is those 3 binomials. X minus 1, x minus 6, x minus 6. Or x minus, not 6, minus 2. Sorry, can't remember right. X minus 2. Okay? Kind of neat. So you know all the spots that graph crosses. All right.